So let's turn in your P2 books to page 9. Now, in this section, we're going to talk about division of polynomials. So we have done addition, we have done subtraction, however hastily, we did those yesterday, and we have done multiplication. So now we can we are going to use multiplication to find our division, because these are reciprocals of each other, they're opposites, they undo each other. So let me put a couple of things up here, because I want y'all to start.
I'm just coming to shake his hand.
Gotcha. Does he need to follow you out the door?
He may, I don't know. He may need, do you have water?
We're
Sometimes
good.
we have to drink water after we shake hands, I guess. Thank you.
Okay, so I'm gonna write a couple of things up here, and I want y'all to see if you can find the pattern. Okay, take a minute, and what I'm really trying to figure out is I'm really trying to figure out how to write this each time. That's what I'm trying to figure out, okay? So think inside your head, then I'll ask for anybody that's come up with a pattern looking at this that will tell you how to write this every time. Make sure it's correct. I'll tell you that this is wrong. We'll put one up here and we'll show that this is wrong. That is wrong. Does anybody think that they see the pattern?
The X's have to be equal.
The X's have to be equal. So tell me tell me to point to something.
Oh wait, it doesn't work for the first one. Never mind.
Okay.
So the exponent on the first one up there is like 2, so you'll have 2.
Okay, you're saying that that's 2.
So
Okay.
you'll have 2 in the second parentheses over there, so AX plus B is 2.
Okay. That's a good observation. Let me throw this one at you. Okay, hold on. So what you said was correct within a very tight restriction, because now I just did that. And you've got 4 here, but you only have 3 here. Okay, good observation, but we're gonna take it, we're gonna expand that a little bit more.
When you multiply the first x by the second x on the right side,
On the right side, when you multiply the first x,
that one and ax,
okay,
it needs to equal the exponent.
okay, that is true. So as long as these were all linear, what you said was absolutely true. Okay, it's when I threw this one in here that this is not linear, this is a quadratic. So look, what was this power? 4, that is 2. Okay, so you have to make sure that these, when multiplied, equal that. So basically, if you look at that gray box and try to read it, everybody read that for a minute. I don't know what it's saying. That's what I fully expected. But that's what it's saying. So let's read it together. It says when a polynomial a of x is divided by a non-constant divisor b of x, the quotient, this part right here, and the remainder are defined by the identity b of x times the quotient plus the remainder. Okay? It says when the degree of the remainder is less than the degree of the divisor, the degree of the quotient is equal to ax minus the degree of bx. So is that not what we just got through saying? And I think I've erased it, but so let me go back to this. This is your ax. This is your bx. This is your quotient. That's your remainder. So the degree of the quotient is equal to the degree of ax minus bx. That's what that's saying. So, hope you understand a little bit better by doing this than trying to read it from that little gray box. Okay, so how does that help us with what we're doing? Well, guys, you don't have to write this down, but we still are on division of polynomials. So, one way you learn to divide is the long division. You do not have to write this down. This would be where you did something like and you divided like that. Y'all remember doing something that looks like that? Or you did synthetic division, which I'm going to take the same example. You would have said x minus 2 equals 0, so x equals 2. You would have put 2 in a box here. You would have listed all these coefficients. Oh, I'm missing the 3, so I need to put a 0 there. And you would have done something that looks like this. Multiply, add, multiply, add, multiply, add, multiply, add. And that's your remainder. Y'all remember doing synthetic. So, you've done 2 types of division. Now, we're not going to focus on long and we're not going to focus on synthetic today. We're going to use what we just learned in the last section that you're having a quiz on tomorrow. And we're going to learn how to find the quotient by doing this method. So look on page 9, example 1.4.1. So they want you to divide x to the 4th plus x plus 2 divided by x plus 1. Okay, so we are going to say, we all know that, all right, let's make this simple. 6 divided by 3 is 2, right? This is the divisor. This is the quotient. So to get 6, I do the divisor times the quotient, right? So I will do the divisor here times the quotient plus the remainder. Well, what is my quotient? Well, that's what we just got finished talking about. So I need to have how many, when I multiply this x, I have to have x to the x to the fourth. So this is going to be ax cubed plus, what will be the next letter? B, x, go down 1, plus c, x, plus, you always have to have a constant, d, plus r. So this time, we're writing out our quotient.
So like the B, C, and D, like that'll always be the same, except
Yes.
the A will just change depending on what that will.
Yeah, the A, so the number of terms depends on where you start, that's right.
Okay.
So with what Chloe mentioned earlier, if this is linear, you know you're gonna have 4 terms. We're not gonna do anything, let me see. I may show you one that your divisor is not linear. Yeah, I'll show you one that your divisor is not linear, not today. But for the most part, all of your divisors are going to be linear. So you know you're going to have 4 terms here plus the remainder. So you always start with A, and you start with 1 less than you have here. And then you step your A, B, C, and then you step down, cube, squared, 1, none. You have to have that none, and then put plus remainder. Okay? So, do I need to work this out for the A, B, C, D, and R? Or can y'all want to see me do it one more time? Yeah, okay. So we're going to FOIL this out or distribute or expand. So that would be, I'm going to leave this alone right here, AX to the 4th plus BX cubed plus CX squared plus DX. So all I did is I multiplied the x by each one of those. Okay, now I'm going to multiply the 1, which makes life pretty easy. Okay, so now I find my A, B, C's, and D's, and R's. So I start off with the x to the 4th. I have no other x to the 4th, so this A is equal to this, so A is equal to 1. Okay, I'm going to start doing it a little bit quicker, so if you want to watch me, you can do it your way or whatever. So now I'm going to underline, I have cube and cube. So I'll leave off the x's, so B plus A has to equal the coefficient of any cubes up here, which are none. So what am I going to put here? My A is 1, so my B is equal to negative 1. Okay, and then I'm going to cross these out because all this stuff kind of can confuse me. So now I have CX squared and BX squared. So I have C plus B. That equals the coefficient of the x squared, which again is 0. So C is equal to 1. Okay, I'm done with those. Now I have dx and cx. So D plus C is equal to 1. D plus 1 equals 1, so D is 0. Done with those. No x's here, so that means that these are constants. Okay? That's your quiz tomorrow, essentially. not setting this up, this will be set up for you, but just doing this. Okay? All right, so we're going to talk about when it's not linear, when your divisor is not linear later. Okay, so now we're going to do the remainder theorem, and this will take all of about 2 minutes. Okay. Look at the box on page 10 that gives you the definition of the remainder theorem. It says if you have a polynomial p of x that is divided by x minus t, then the remainder is p of t. Okay, let me put that in plainer English. I know. That's the reason why I'll never write a textbook. So, let me ask you this, okay? If I asked you to divide, all right, hold on. I'm going to do this. What do you need? You need a value of what? If we did synthetic division, what would I put in the box? -1. -1, where did that come from, Amy?
It's x plus 1 is 0.
All right, so you actually need a value of x. Okay, you need to store x in here, right? You need a value of x. So f of x equals this. So in order to get my output, my input has to be x. Well, if I have x plus 1, what is x equal to? -1. So, do I have a -1? That means that that is -6. This, my dear people, is your remainder. So the short of it is you solve for what x is. So now let's look up here and see if that makes sense with the long drawn out explanation that they gave us. So what's in the parentheses here? X. If I set that equal to 0, then what is x equal to? T. So if x is equal to t, then what am I putting in place of the parentheses now? The t. That's how they explain that. But here's all you have to do. If I tell you to find the remainder of this, divided by this, write it down. You're going to find the remainder. You have got to get, for your input, you have got to get a value of x. Well, what's my value of x? 7. So you're going to take your calculator out, and you're going to store 7 as x. And then you're going to type this in. And tell me what the remainder is. Did everybody get that? I don't know what it is. I don't have my calculator up here. That's it. That's the remainder. So all you're doing is storing a value of x, plugging it into the equation, and whatever pops out is your remainder. Okay? So the next thing I want to do is talk about the factor theorem. This goes hand in hand with remainder. Okay? Tell me, think about the number 6. Is 3 a factor? Is 3 a factor of 6? Yes or no? Yes, it's not a trick question. Okay, is 4 a factor of 6? Okay, well tell me. You've known this, you've known it since you could divide in 4th grade. What makes 3 a factor of 6? And in terms of what we just talked about, it has no remainder. The remainder is 0. So tell me what you think the factor theorem is. Is x minus 7 a factor of 3x squared plus 2x minus 7? No. Why? It's not a remainder of 0. That's factor theorem. So if I ask you if this is a factor of this, or if this is a factor of this, you will tell me yes or no by checking the remainder. Okay? So let's put that to some use. So give me just a minute, and I gotta think of a good one so that you can't just do it in your head. Hold on just 1 minute. we need to store as x? All right, so we don't store negative 1. We don't take just the opposite. So we do 2x equals negative 1 divided by 2. So negative 1/2 is what you store. And yes, that one is. Oh, yeah, yeah.
Was it 3 before? Or has it been
No,
13?
it was 13. That's all right, that's all right. Okay, so that's the factor theorem. Okay, and then the last of the new stuff we're going to talk about is the rational roots, and this is not in your book, theorem. Just another section. Okay, you need to write that down because this is a formula that you have to know. And it's not hard. The hardest part is remembering what goes where. Okay, so what I've written up here is to find all possible. So does this allow you to find only the only roots? It's just the possible rational roots. And rational. Tell me what rational means. If a number's rational, it can be written as a fraction or integer. E is not rational. The square root of 2 is not rational. Pi is not rational. Don't tell me it can be written as a decimal, because pi is a decimal and it's not rational. It can be written as a fraction. The only time as a decimal is if it is repeating, like 0.3 repeating would be 1/3, or if it's terminating, 0.125 would be 1/8. But just to say a decimal is incorrect. So let me show you what this means. All right, so I want to find all the possible rational roots of that. The possible rational roots. These are not the rational roots. They're just possible. So, you have to list the factors of the constant. Well, what is my constant? If you don't know what the constant is, you don't even know what you're looking for. What is the constant in this problem? 5. So what are my factors of 5? Now, we don't worry about it being plus or minus here. The first factor is always and forever 1. Never leave 1 off. And then the other is 5. Now, what is your lead coefficient? 3. So you have 1 and you have 3. So now we have to simplify that. And here's what I do. I take this number first, and I put a plus or minus. What's 1 divided by 1? Plus or minus 1 divided by 3. Then I'm done with that one. Then I do 5 over 1 and 5 over 3. So you have 1, 2, 3, 4, 5, 6, 7, 8 possible rational roots for this. This is gonna lead us to something else tomorrow. I'm gonna stop right here on this one, but I'm gonna give you some work to do. All right, we're gonna go back, and this is gonna be your classwork right now. Let me stop this.